Here the problem is find Fourier series of the function f of x if f of x is defined in the interval minus pi to pi as f of x equal to minus pi in the interval minus pi comma 0 and f of x is defined as x at 0 to pi. F of x is defined in the interval minus pi to pi, but in between f of x is defined in between minus pi to pi, but the interval is break at the point 0. In between minus pi and 0, f of x is defined as minus pi, and in between 0 to pi, f of x value is x. That means the function f of x is discontinuous at the point 0. Here f of x is called the points of discontinuity at 0. Okay, f of x definition is like that. So for this f of x, find the Fourier series. Hence deduce this reduction. So after finding Fourier series to this function in the interval minus pi to pi, we try to obtain the deduction. Already we know Fourier series for the function f of x is given by f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx plus bn sin nx. This is Fourier series expansion to the function f of x. Here a0, an, bn are Fourier coefficients. Already we know the formulas to find the Fourier coefficients. So to find Fourier coefficients a0, an, bn, the formulas. To find a0, formula is a0 equal to 1 by pi integral. Here f of x is defined in the interval minus pi to pi. So a0 equal to 1 by pi minus pi to pi f of x dx. But in the whole interval f of x is not defined. In between minus pi to 0 defined as minus pi and 0 to pi defined as x. So break the interval minus pi to pi as minus pi to 0 plus 0 to pi. In between minus pi to 0 defined as minus pi. So in place of f of x minus pi dx. And in between 0 to pi, f of x is defined as x. So write down here x dx equal to 1 by pi minus pi integral dx is x, limits minus pi to 0 plus integral x value x square by 2, limits 0 to pi. So 1 by pi into here lower limits, upper limit substitution 0 and lower limit substitution in place of x minus pi. So minus pi into minus pi, that is pi square, plus pi square by 2, lower limit substitution 0. So equal to 1 by pi of minus pi square plus pi square by 2 equal to 1 by pi, the value minus pi square by 2. So minus pi by 2. Therefore a0 equal to minus pi by 2. To find an, formula is 1 by pi integral minus pi to pi f of x. To find an, formula an equal to 1 by pi minus pi to pi f of x cos nx dx. But f of x is defined at minus pi to 0, that is minus pi to pi break at 0, and in between minus pi to 0 it is defined as minus pi, and in between 0 to pi defined as x. So 1 by pi, here minus pi to 0 f of x is defined as minus pi cos nx dx plus in between 0 to pi it defined as x cos nx dx equal to 1 by pi minus pi constant. Integral cos nx is, actually you will get here confusion. Integral of cos, derivative of cos is minus sine, that is very clear to us. So integral of cos means sine function. Try to remember like that. Limits minus pi to 0. Plus here under the integral, product of two functions, algebraic and the trigonometric. So take u equal to x, u dash becomes 1, u double dash 0, and v equal to cos nx, v1, that means integral of cos is sin nx by n, v2 equal to, again integral of this, integral of sine means minus cos nx by n, already here one more n, so n square. So generalized rule of by parts formula is integral uv dx equal to u v1, u is x, v1 is sin nx by n, u v1 minus u dash v2, in v2 you have one more minus sign, that's why plus cos nx by n square, u v1 minus u dash v2 plus u double dash v3. As already u double dash 0, the formula will be stopped. So here limits 0 to pi equal to, here pi cancel. If you substitute in place of x 0, sin 0 0, minus in place of x minus pi, sin of minus n pi, that is minus n pi, that is also 0, plus, and this is 1 by pi common to this expression also, so 1 by pi, and if you substitute upper limit pi, sin n pi, you will get 0, plus here cos n pi, the value is minus 1 whole power n by n square. This is upper limit substitution, minus of lower limit 0. 0 into this term 0. Here cos 0, that is 1 by n square. So an equal to 1 by pi minus 1 whole power n minus 1 by n square. An Fourier coefficient. To find next Fourier coefficient Bn. To find Bn, formula is 1 by pi integral minus pi to pi f of x sin nx dx. So it is equal to 1 by pi. Here the interval bracket 0, so minus pi to 0 f of x sin nx dx plus integral 0 to pi f of x sin nx dx. Now already we know at the interval minus pi to 0, f of x is defined as minus pi, so sin nx dx, plus, and in between 0 to pi, f of x is defined as x, sin nx dx equal to 1 by pi minus pi constant, integral of sine is minus cos nx by n, limits are minus pi to 0, plus here under the integral product of two functions u and v, where u equal to x, so u dash becomes 1, u double dash 0. V is sin nx, so v1 is integral of sine minus cos nx by n, v2 equal to minus integral of cos is sin nx by n square. So if you apply by parts formula integral uv dx, by observing these symbols we will get as uv1, u is x, v1 is minus cos nx by n, u v1 minus u dash is 1, v2 is minus sine, So already minus sign, so plus sin nx by n square, uv1 minus u dash v2 plus u double dash v3. Actually u double dash 0, so the formula will be stop. The limits are from 0 to pi. So equal to, here minus pi cancel, minus minus plus, so you will get cos nx, limit cos nx by n, limits minus pi to 0, and this 1 by pi to this term also, plus 1 by pi, here minus x into cos nx by n plus sin nx by n square, limits 0 to pi. Now apply the limits. Upper limit cos 0, so 1 by n, minus lower limit in place of x minus pi. Already we know cos of minus theta means cos theta itself. So here cos of minus n pi you will get. Cos of, in place of x, if you substitute minus pi, you will get cos of minus n pi. That means cos n pi itself. So the value is minus 1 whole power n by n plus 1 by pi. Now here in place of x, pi. So minus pi, minus 1 whole power n by n. And in place of x, pi, sin n pi, the value 0, minus of lower limit substitution, 0 into something, 0, plus here sin 0, 0, equal to 1 minus minus 1 whole power n by after that 1 by n minus power n, pi cancel, you will get minus 1 whole power n by n, so equal to 1 by n. Here we have two terms, so minus 2 minus 1 whole power n by n. It can be written as on the whole n by n. This is Fourier coefficient Bn. Now we got A0, An and Bn Fourier coefficients. A0 Fourier coefficient equal to, therefore we got A0 equal to minus pi by 2, An equal to 1 by pi minus 1 whole power n minus 1 by n by n square. Bn equal to 1 minus 2 minus 1 whole power n by n. 3 Fourier coefficients we got. Therefore, Fourier series of f of x, Fourier series of f of x given by f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx plus bn sin nx. It is equal to a0 by 2, that is minus pi by 4, plus sigma n equal to 1 to infinity an value 1 by pi minus 1 whole power n minus 1 by n square cos nx plus bn value 1 minus 2 minus 1 whole power n by n sin nx. It is so f of x equal to, this is the required Fourier series expansion to the function f of x. So here in this problem they ask find Fourier series to the function f of x. After finding Fourier series, hence deduce that the reduction. In order to get the reduction, this we got the Fourier expansion. Expand this summation and observe the terms of the expansion and what are the substitutions we have to take in place of x to obtain the required deduction. That is the procedure here we are going to follow. So here first if you expand the sigma by taking n equal to 1, here 1 by pi. Take n equal to 1. If you take n equal to 1, you will get minus 1. So minus 2 by 1 square. In place of n, we are taking 1. So cos x. First expand this term. Later we expand the sine term. So plus take n equal to 2. If it already we have taken 1 by pi common. So take n equal to 1 over. Now take n equal to 2. If we take n equal to 2, it will be even. So 1. 1 minus 1, 0. So in this expansion for this term, for n equal to 2, 4, 6, we won't get the value. It will be 0. Now for n equal to 1 over 2, at n equal to 2, we got 0 in the numerator. So value 0. Now for n equal to 3, you will get minus 2 by 3 square cos 3x. Now n equal to 4 means it becomes 1. 1 minus 1, 0. Already we know. Now n equal to 5, you will get minus 2 by 5 square cos 5x. Like that it follows. Now plus to this term, sine term, take n equal to 1, 2, 3 and so on. If we take n equal to 1 here, minus 1. Minus 1 means minus minus plus. 1 plus 2. That is 3. You will get 3 by 1 sin x. Next term. N equal to 2 means it will be value 1. Minus 1 whole square. So value 1. 1 minus 2. Minus 1 you will get. So minus 1 by 2. For n equal to 2 we are doing. So minus 1 by 2 sin 2x. Now plus n equal to 3. N equal to 3 means minus 1. That is the value 3. 3 by 3 sin 3x. Like that we will get the expansion to sine term. After simplifying this one, you will get okay. After this, now observe the terms of the deduction. In the deduction you got they given 1 by 1 square, 1 by 3 square, 1 by 5 square. So in the expansion you got 1 by 1 square, 3 square, 5 square. Means we won't require these. Sine terms we won't require. That means sine function values at x equal to 0. So put x equal to 0 in the above expansion. So that f of x here, that means f of 0 equal to minus pi by 4 plus 1 by pi cos 0, value 1. So minus 2 by 1 square minus 2 by 3 square minus 2 by 5 square minus and so on. Plus here in each term we have sine function, sine 0, 0. It is equal to minus pi by 4, and if we take minus 2 by pi common, you will get minus 2 by pi. 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus and so on. And we need f of 0 value. To find f of 0 value, in the given function at 0 we have break. Function is break at 0. That means function is not defined. Function is not continuous at 0. This type of functions called functions having points of discontinuity. Only the function f of x is discontinuous at the point 0. But we require Fourier series value at 0. So here clearly function defined in between minus pi to pi, and at 0 the function is discontinuous. So in between these 2 points function defined as minus pi, and in between 0 to pi according to given information it is x. So we want to know f of 0 value. That means a function discontinuous at the point 0. We require this value. So right hand limit is f of 0 plus. Function discontinued at 0. Its right hand limit value means this side the value is x, f of 0, that means 0. We are finding at 0, so actually it is defined as x, but in place of x we are taking 0, so value 0. Now left hand limit. Left hand means this side. So this side defined as minus pi. So to find f of 0 value, that is f discontinuous at 0, but to find Fourier series value at the discontinuous point, we take the arithmetic mean of both the left and right hand limits. This is the left limit, this is the left limit, and this is the right limit. We take the arithmetic mean of left and right limit. So equal to minus pi by 2. So the value of f of 0 is minus pi by 2. So next shift this point to another side. Minus pi by 2 plus pi by 4 equal to minus 2 pi pi 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus and so on. The value is minus pi by 4. Shift this term to this side into pi by minus 2 equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on. So pi square by 8 equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square. So this is the required deduction from the Fourier series of the function f of x. This completes the solution.